Hi everyone, I'm Stephen and welcome to Audio Nautica. I've got this monstrous Sansui AU-X11 is on the bench, and as you can see the covers are off. Now that might be concerning, but it is working well and I plan to keep it that way. It's a bit of an interesting story as to how this all started out. So I bought this integrated amplifier from a dealer in Japan. It came with a 2-year warranty, and I can tell by looking inside of it that they really have gone through this extensively. You might be able to see that, just here we've got a bunch of electrolytic capacitors have been replaced. I can tell just by looking at it that they really have put some fantastic TLC into this. And it's been working well, so no real reasons to worry except for one thing, and that is that I could smell this rather distinct old electronics kind of smell coming out of the amplifier. And electronics kind of smells are not a good thing. Now, I've been in electronics long enough to know what a burning smell smells like, and it was not a burning smell. And if it was a burning smell, you've got really big trouble immediately. But this rather pungent smell, I knew I recognized the smell, but I couldn't put my finger on what it was, and it shouldn't have been there. And it was coming from a very, very localized place in the amplifier using my calibrated sniffer, my nose. Basically, so what you've got here is you've got your two power amplifier modules. So the actual power transistors are bolted onto these heat sinks, one there and the other one's underneath this bit of paper. And so these are the driver boards that drive those very high speed, high bandwidth power transistors. And I could tell using my nose that this strange smell was coming from basically right here. There's this column of warm air comes up on both of these boards, and on this board it was from here that this very strange smell was coming from. So I was really quite concerned as to what did this smell indicate. So I decided that I would dive in and investigate what was going on. Now, I did actually make a video of the disassembly, but that video was really for me so that I could be able to work out how to get the thing back together. So I'm not going to show you that video because it's just really quite boring, trust me. But these use kind of a bunch of solder-in bayonet kind of connectors. So there's one just there, there's one just there going into the back of the board. There's a bunch of them. So to get the board out, you have to remove those. And on the bottom side, there's some very, very high gauge wires that have to be desoldered as well. So in resoldering those, one has to be really, really careful, because if you had a joint that wasn't up to scratch, was a bit dry or something, you could end up with really, really big problems. So you certainly need to have the right kind of soldering gear. It's not for the faint-hearted to attempt this. So anyway, I took the board out and gave it a really good inspection, couldn't see anything. However, what I could see is that there were a couple of places here and there was just a bit of flux on the board. And just in the process of reworking the board and getting it ready to reassemble it, like cleaning out the solder from holes to get these bayonet connectors to go back in and so on, it's then that the light bulb went off in my head. Hang on, I know what that smell is. The smell is flux. Back in the day, flux, well, I think flux smelled kind of different to what modern fluxes smell like. If I use some modern solder, you don't really get that kind of old flux smell. But if you rework, say, an old amplifier or a VCR or whatever from the 1970s, the 1980s, the flux has a very, very distinctive sort of smell. And I knew that I'd smelt the smell before, but I couldn't remember what it was, because it's a while since I've worked on anything with that kind of smelly flux in it. And so, yeah, so that's what the smell was basically, is I think there just must have been a bit of residue of flux, probably from when the dealer reworked all of these boards, probably just missed a little bit of flux or didn't quite clean the board up 100%. And so what I think what there was is this section which gets quite warm, there would have just been a little bit of flux on something that got warm, and as it warmed up, it really kind of like started to bake that flux smell out of it. And I certainly did notice that the smell got a lot stronger when the amplifier had been running for a while, when it had sort of like warmed up. So anyway, in the process of all of that, I had to clean the board up, as I mentioned, and when I cleaned it up and put it all back together, the smell's gone. So I'm absolutely convinced that that's what the strange smell was just a bit of hunk of flux on this board somewhere that was getting warmed up, and the smell was coming up through here, and that's what I was smelling. So that's resolved, which is great, but I just wanted to have a kind of a level of assurance, I suppose, for myself that this amplifier is where it should be at. So that's what it's hooked up for at the moment. So the measurements that I'm making on this bias or idle current or quiescent current, whatever you want to call it, and DC offset, those are the two critical measurements in just about any amplifier. Certainly bias current, every amplifier that I know of pretty much anyway, will have a bias current. That's to do with the way that transistors work, is that you don't want the transistors to be switching on and off, because there's this 0.7 volt drop, so it will seriously distort your signal. So that's why you bias the driver transistors so that they are on all of the time, and the signal basically just changes how much they are on. So the amplifier is always consuming a certain amount of power, and from there it makes the noise either side of that bias, if you like, if that makes any sense. You can look up the theory for yourself. So anyway, so that's what the bias is. And the DC offset is, well, obviously you don't want any DC on your speakers, because that will kill your speakers. DC on speakers is always bad. And it's especially critical on this amplifier, because this amplifier is capable of amplifying from DC, basically up to about 300 kilohertz, I think it goes. So, so yes, the DC offset is quite critical on this amplifier as well. And however, DC offset is not something that needs to be adjusted on all amplifiers, because some amplifiers will have transformer output coupling. So a transformer by definition cannot pass DC. So if you have transformer outputs, which you usually would on a valve amplifier, then there's no DC offset adjustment on those. And also if you have a capacitively coupled output, so going through a capacitor, again, there can't possibly be any DC on that, because capacitors can't pass DC, so there won't be any DC offset adjustment on a capacitively coupled amplifier either. This amplifier is neither of those. The output is driven straight from the output transistors, so yes, it is capable of putting out DC, so you need to adjust the DC offset to make sure that there isn't any DC on the output. So the amplifier does need to be warmed up. So it needs to have been running for about half an hour. So we've got another 20 minutes or so before it's ready to check these final adjustments. So when it's got to that state, I'll be back. Okay guys, we are back, and this thing has been running for half an hour now, and you can tell that it's getting nice and warm and toasty. So I'm going to show you a few things, but just before I do show you a few things, I want to say something quite important. I've had a few people make comments on other videos saying things along the lines of, it would have been nice if you'd have shown us exactly how to blah blah blah. Now, unless I specifically say that my video is intended to be an instructional video, it's not. Okay? I'd like to think that all of my videos are informative videos, but generally speaking, they are not meant to be instructional videos. And the reason for that is that you cannot do this by blindly following someone else's video. Okay, you can learn things from someone else's video. I've learned a lot of things by watching other people's videos. But I have a background in electronics theory. And unless you have that background, unless you know what you're doing, then the chances of something catastrophic happening, especially on an amplifier like this, are especially high. So, I'm being really, really careful on this because, this is the highest end amplifier that I've ever worked on. Certainly it's the most complicated technologically. I'll happily work on a NAD 3020 because if it blows up, no huge loss. But blowing one of these up is a completely different kettle of fish. And this thing is far, far, far more complicated than a NAD 3020. So I would respectfully suggest that if people are feeling that they need to be shown exactly what to do for how to align an amplifier, then really you probably shouldn't be doing it. Okay, I know there's a first time for everybody, and I had my first time, and I actually blew the amplifier up not this one, a different amplifier. I blew it up the first time because of a fault in my multimeter. So I just ask people to please take that on board, that that's not what these videos are about, is showing you exactly what to do. You need to convince yourself that you have got the prerequisite technical skills and knowledge before you dive into a task. And there's other ways of getting that. You don't learn electronics by watching YouTube videos, okay? So, having said that, I'm going to show you a few things. So, one of the things that we can look at in getting some ideas about an amplifier is its temperature, how it's running. So I had this is a little laser thermometer, and I had this kicking around on the bench on the shelf, and it works pretty well. And where's it gone? So if I point it, I know you can't see it, but if I point it at this, this is one of the dual FET devices. It's about 37 degrees, 36 degrees or so. So I can get an idea just by using this thing as to where the hottest part of the board is. And if you've got a fault condition, getting an idea as to what is hot is a good idea. So yeah, this is a handy kind of a tool to have. However, I just got this, and I haven't actually tried this yet, so I'm about to try this. Fire it up. I got this on eBay. I have had a bit of a fiddle around with it, but this is the first time that I've ever used it on this amplifier. And I've got to say, yeah, it's got these various modes. I'm actually really impressed with the way that this thing works. So yeah, you can see it's got these different modes. You just have just heat mode. I think this is pretty cool. It's like line drawing mode. But then yeah, here I'm seeing, I think this is a black and white version. Now that's full color, but it's not showing me the thermal graph. So I can overlay, yeah, like that. I can overlay the two of them. So basically with this, I can tell straight away what is hot. So I'll just see if I can bring you guys up here so you can see. Just adjust everything so that, get that reflection out of the way, go away, there we go. So I can kind of like point at things. So So yeah, I can see the back of that board is about 39 degrees, and then if I come over here, so I know that dual JFET, yeah, it's about 40 degrees. So, and it is a little bit tricky because the board is like on its side. But yeah, so if there was a component that was like running really, really hot, for example, then this would be really, really handy for debugging. So I think this was about, I think it was about 250 bucks on eBay, and yes, it was one of the cheaper Chinese ones, but it's actually far better than I thought it was going to be for the price. And it can take screenshots as well. Like there's a little SD card in here. I haven't actually tried that functionality yet, but yeah, I think it's pretty cool, pretty handy little device. So that's enough of that. Let's get on to the adjustments. So there, as I mentioned before, there are 4 adjustments. Ideally, you want 2 multimeters to do this. 4 is better. I realise most people don't have 4 multimeters. I've got 3.5. 3.5 multimeters, you say? Well, I'll show you in a tick. So, DC offset, I'm measuring that straight out of the speaker jacks. Obviously, if you actually had a fault where the unit's gone into fault protection, that won't do you any good because it'll disconnect the outputs from the amplifier. But that's not the case here, so I can measure the DC offset straight out of the speaker jacks. So I've got one channel is connected to this handheld multimeter, and it's measuring about 1.3 millivolts. Now, the Keithley here has got a front input and it's got a rear input. So the front input I've got measuring the BIOS on one channel. The rear input is connected to the DC offset of the other channel. So that's why I say I've got 3.5 meters. So the other multimeter is this one here, the DM502A in the Tektronix TM5006 chassis. So, the DC offset is adjusted just by a couple of potentiometers. I am just going to try to give it just a little bit of a tweak. As you can see, it's hovering about 1 millivolt on one channel and about 1.7, 1.8 millivolts on the other channel, which is pretty good, but I think it should be possible to get it below 1 millivolt. So on the preamp module, it's this pot here, which is up the top, and I'm using this little alignment tool. You'll see when I go to adjust the bias that I have to use this kind of tool. So I'm not actually sure which one is which here, so we'll just see which one changes. And you know, we're talking about just the tiniest touch. You can't actually turn it so much because the turn will just send you kind of way out, if that makes any sense. So it's just about trying to transmit just the tiniest little tweak through this shaft while it's loaded. Okay, so it's the Keithley that I'm looking at. .3, and of course when you release the force, it just kind of tweaks back up again, if that makes any sense. So .1 of a millivolt. I don't think I'm going to do any better than that. Let's try the other channel. 0.3. Don't think I'm going to do any better than that either. So now if I just go back to the bias, so this one's currently reading about 19.7 millivolts, this one's reading about 13.9. I'm going to adjust this to about 15 millivolts. This has been done after a fair bit of consideration. There is no service data available for these AU-X11s. There's various information floating around. Some people on the forums seem to have settled on 11 millivolts. The AU-X1, which is kind of like the predecessor to this, very similar design. I think it recommends 25 millivolts. However, the output stage is not the same. So you can't just say that it should be that because that's what the AU-X1 is, but you can get an idea by idle power. And so what I have got is just one of these little line power meter things, and so it's telling me how much power this is consuming. So it's about 102 watts that it's consuming at the moment. So also I do have a 100 volt step down transformer, and that's taking about 6 watts. So you can get an idea as to whether you're kind of in the ballpark as to what you're aiming for by what the idle power is. So something that's around 100 watts for this amplifier is probably a good kind of a place to be. Something wildly different from that indicates that there's something probably wrong. I kind of like want to be middle of the road as well, so I think I'd feel a little bit uncomfortable being up around 20 or 25 millivolts. Now I did measure this before I adjusted these originally. One channel was reading 17 millivolts, the other one was reading 20 millivolts, so it may have been adjusted for 20 millivolts, but this setting is so finicky. And remember, this thing's been on an aeroplane from Japan to here, and honestly by the time I put the lids back on and carry it back to my system, even that is probably going to slightly change it anyway. Which is why I'm probably kind of happy with a middle of the road setting like 15 millivolts. So I'm going to dive in and do that. Now the reason why I have to use this insulated tool is because you're probably not going to be able to see, but the potentiometer is down in there. So to adjust that, I've got to kind of slide this down here, and if I was using a normal screwdriver, I'd be shorting things out, and that's not good. So that's why I need to use that tool. And so if I just now adjust this, I want it to be 15, and again I just got to apply force so carefully because I don't want it to get away from me, if that makes any sense. Did you see that? I had it right, and then just in the process of just when I pulled the screwdriver away, it drops back down to 14. That's how tricky this is. Some people have suggested using a multi-turn pots. I think that's probably got a lot of merit in it, to be honest, because it's such a tiny window of adjustment on this pot. So I think it would be a whole lot easier to adjust with a multi-turn trim pot. Oh, come on. You can just see the difference in when I just apply the turning force to the pot, it sends the reading up. Okay. It's out and it's reading 15.0. Just so finicky. Let's do the other one. So finicky. I think that's probably about the best I'm going to be able to do. I mean, again, it's not really critical whether it's, 14 or 16. I'm just aiming for a target. Yes, the two should be fairly similar. Now, you wouldn't want one as 10 and the other one as 20. Probably still work fine. It probably sounded fine. But, yeah, you want them to be fairly close together. Although, no, I'm still not happy with that. Still not happy with that. Come on, baby. Oh, it is just so finicky. And just because of the clearance issues, it's just so hard also to get the screwdriver in the right place. Just see if I can give the other channel just the tiniest kick. .0, I think I'll take that. Yeah, so I think this gives you an idea as to just how absolutely finicky this can be. So I'm just going to let this sit here for a while. Just make sure that these are stable. DC offset is stable. DC offset, yeah, 0.2 of a millivolt. That's pretty good. Because you do need to make sure that they don't kind of interact. Sometimes they can. So yeah, I'm just going to let this sit here just to make sure that these stay stable. The power on the power meter is bang on 100 watts, so it'll actually be more like 95 because it's about 6 watts or so is taken by this transformer. So yeah, so that's where we are at with this. What I'm going to do too before I put the covers back on is turn it off, let it all cool down, turn it back on, and just make sure that it comes back to the same place. Because I think it's kind of normal for the bias to, I mean, hunt is not the right word, but as it comes up to its idle temperature, the bias can float around a fair bit. So I just want to watch that. So yeah, so that's the plan. And yeah, I'll be back soon. Okay everyone, we are back, and I've allowed this to cool down to stone cold overnight, and I fired it up again, and it's almost settled down. So what's clear is that it actually needs to run for longer than half an hour for everything to stabilize. So it's now been running for 3/4 of an hour, and those bias readings are still continuing to fall. But I'm pretty satisfied that in another 15 minutes or so, they will settle down to more or less what I set them to yesterday. So I'm not going to continue to chase my tail on those, but yeah, it's important, I guess, to have that understanding as to, not trying to make adjustments while the unit is still settling down to its, warm, toasty, quiescent state. So yeah, it probably needs to have been running for about an hour or so before it will actually settle down. At least that's the case for this AU-X11 anyway. So I'm going to wrap this video up. All that's to be done now is basically put the covers back on. So I hope you enjoyed this video. Please give me a like, please subscribe to my channel, it helps me so much. If you want to see more of these videos, you can support me on Patreon. And I look forward to seeing you on the next video. Bye for now.